Azure Virtual Machines, or VMs, represent a cornerstone of Azure's core compute services, offering on-demand, scalable computing resources. As an infrastructure as a service, or IaaS, offering, VMs provide users with unparalleled control over the operating system, installed applications, and middleware components. This contrasts with platform as a service or software as a service, where more of the underlying infrastructure is abstracted. With Azure VMs, you provision virtual servers within Azure's global data centers, choosing from various operating systems, including Windows and Linux, and customizing hardware specifications such as CPU, memory, and storage. Azure manages the virtualization host, network infrastructure, and physical data center, while you retain responsibility for OS patching, application maintenance, and data management. This model is particularly well-suited for lift and shift migrations of existing on-premises applications, development and testing environments, or running custom software that requires specific operating system configurations, providing the ultimate flexibility and control over your cloud environment. Azure Virtual Machines provide robust solutions for diverse computing needs. A primary use case involves the seamless migration of existing on-premises applications and workloads to the cloud, leveraging Azure's scalable and secure infrastructure without extensive re-architecture. VMs also serve as an indispensable resource for development and testing environments, offering isolated, reproducible, and easily provisioned sandboxes for software engineers. Furthermore, they are critical for running specialized software, including high-performance computing, or supporting legacy applications that require specific operating system configurations, ensuring operational continuity and adaptability within a modern cloud framework. Azure Virtual Machines, or VMs, are a cornerstone of Azure's infrastructure as a service offering. They provide on-demand, scalable compute resources, granting users complete control over the operating system, applications, and configurations, much like a physical server, but within Azure's globally distributed infrastructure. This service supports a comprehensive array of operating systems, including Windows and various Linux distributions, enabling the deployment of diverse application workloads and development environments. Azure VMs are designed with robust scalability in mind. Vertical scaling allows for the resizing of a VM by adjusting its CPU, memory, and storage to meet evolving performance demands. For horizontal scalability, Azure Virtual Machine scale sets automate the deployment and management of hundreds of identical VMs, automatically adjusting capacity based on real-time demand and predefined metrics, thereby ensuring high availability and fault tolerance for mission-critical applications. Azure App Services represents a robust platform as a service, or PaaS, designed for the efficient creation, deployment, and scaling of web applications, APIs, and mobile backends. As a comprehensive PaaS offering, it effectively abstracts away the complexities of infrastructure management, including server provisioning, operating system updates, and runtime environment configurations. This empowers development teams to concentrate exclusively on application code and core business logic. Azure App Services provides extensive language support, including .NET, Java, Node.js, Python, and PHP, among others, ensuring broad compatibility. Key features include integrated automatic scaling capabilities, seamless continuous integration and deployment with leading DevOps tools, and robust security protocols, all delivered within a globally distributed and highly available architecture. This managed environment significantly reduces operational overhead, accelerates time to market, and guarantees reliable performance for enterprise-grade web solutions. Azure App Services provides a fully managed platform as a service, or PaaS, designed to host web applications, RESTful APIs, and mobile backends with enterprise-grade performance and scalability. It supports a wide array of programming languages and frameworks, including .NET, Java, Node.js, PHP, and Python, allowing developers to utilize their preferred tools. Key features include automatic scaling to meet demand, integrated continuous integration and continuous deployment pipelines, deployment slots for zero downtime updates, and robust security capabilities. By abstracting infrastructure management, Azure App Services enables organizations to focus solely on application development and innovation, ensuring rapid deployment and efficient operation of their digital presence across web, API, and mobile platforms. Azure App Services offers sophisticated features for managing application deployments and performance. Deployment slots provide isolated environments, such as staging or testing, distinct from the production environment. This capability allows developers to deploy new versions of an application, conduct thorough testing, and then perform a near-instantaneous swap with the production slot, ensuring zero downtime for end users. This process is critical for continuous integration and delivery pipelines, enabling safe rollouts and efficient rollbacks if necessary. Concurrently, App Services auto-scaling capabilities ensure applications maintain optimal performance under fluctuating demand. By defining rules based on metrics like CPU utilization, memory consumption, or HTTP queue length, the service automatically adds or removes application instances. This elasticity guarantees that resources are provisioned precisely when needed, preventing performance bottlenecks during peak loads and optimizing costs during periods of low activity. Together, deployment slots and autoscaling form a robust foundation for building highly available, resilient, and cost-effective cloud-native applications on Azure. Azure Functions represent Azure's serverless compute offering, specifically designed for event-driven workloads. This service enables developers to execute small pieces of code, known as functions, in response to various events without the need to provision or manage the underlying infrastructure. Functions can be triggered by a wide array of sources, including HTTP requests, changes in a database, messages in a queue, or timers. A key advantage of Azure Functions is its automatic scaling capability, which dynamically adjusts resources based on the incoming event load. This ensures high availability and responsiveness while optimizing costs, as you only pay for the compute resources consumed during the actual execution of your functions. Azure Functions seamlessly integrates with other Azure services, making it an ideal choice for building highly scalable, cost-efficient, and responsive microservices, real-time data processing pipelines, and back-end APIs. Azure Functions provide a robust serverless compute platform, with three core concepts defining their operational paradigm: triggers, bindings, and orchestration. Triggers are the event sources that initiate function execution. These can range from HTTP requests and timer schedules to messages appearing in a queue, blobs being added to storage, or events arriving in an event hub. They define when a function runs. Bindings offer a declarative way to connect functions to data, simplifying code by abstracting away the complexities of interacting with other Azure services. Input bindings provide data to the function, while output bindings send data from the function, seamlessly integrating with services like Azure Storage, Cosmos DB, and Event Hubs. Finally, orchestration, primarily enabled by durable functions, allows developers to build stateful, long-running workflows with serverless code. This capability facilitates complex patterns such as function chaining, fan-out/fan-in, asynchronous APIs, and human interaction, transforming a collection of stateless functions into a coherent, resilient application workflow. Together, these features empower developers to build highly scalable, event-driven applications with minimal operational overhead. Azure Functions, a cornerstone of serverless computing within Azure, offers robust capabilities for developing agile microservices and streamlining automation workflows. In microservices architectures, functions serve as highly scalable, event-driven units capable of responding to HTTP requests for API backends, processing messages from queues, or reacting to database changes. This enables the creation of loosely coupled, independent services that are easy to deploy and manage. For real-time data processing, functions efficiently handle streams from sources like IoT devices or event hubs, executing logic with minimal latency. Furthermore, Azure Functions excels in automation scenarios. It can execute scheduled tasks, orchestrate complex workflows by reacting to various triggers, and integrate seamlessly with other Azure services and external systems to automate administrative operations, data transformations, or continuous integration, continuous deployment pipelines. Its pay-per-execution model and automatic scaling make it an exceptionally cost-effective and efficient solution for on-demand processing and scheduled operations. Azure Container Instances, or ACI, offers a fast and straightforward solution for running containers in Azure without the need to provision or manage underlying virtual machines, and, critically, without the overhead of a full container orchestrator like Kubernetes. ACI abstracts away the server infrastructure, allowing you to focus purely on your containerized applications. This service is particularly well-suited for scenarios requiring quick deployment of individual containers, isolated tasks, batch processing jobs, or event-driven applications that don't demand the full feature set and complexity of an orchestrator. ACI provides rapid startup times and offers per-second billing, making it a highly cost-effective option for burstable and transient workloads. It's the ideal choice when you simply need to run a container, quickly and efficiently, directly in the cloud. Azure Container Instances, or ACI, offers the fastest way to run containers in Azure without the overhead of managing virtual machines or orchestrators like Kubernetes. This serverless container service enables rapid deployment, allowing you to get your containerized applications up and running in a matter of seconds. ACI's significant advantage lies in its granular billing model. You are charged solely for the precise duration your container is active, down to the second, eliminating the need to over-provision resources or pay for idle capacity. This cost-effective approach makes ACI exceptionally well-suited for burstable workloads, event-driven applications, and simple containerized tasks where quick scaling and optimized expenditure are paramount. ACI streamlines container deployment and operational costs, providing a lean and efficient execution environment for your applications. Azure Container Instances, or ACI, presents compelling scenarios for both batch jobs and development workflows, primarily due to its serverless nature and rapid deployment capabilities. For batch processing, ACI excels by providing on-demand, isolated container execution for short-lived tasks, such as data processing, media rendering, or extract transform load operations. It eliminates the overhead of managing virtual machines, allowing resources to be provisioned and deprovisioned precisely when needed, ensuring cost efficiency and operational simplicity for burstable or intermittent workloads. In development and testing, ACI significantly accelerates the development lifecycle. Developers can rapidly prototype containerized applications, deploy isolated testing environments on demand, and seamlessly integrate ACI into continuous integration and continuous delivery pipelines. This enables quicker iterations, faster feedback loops, and a more agile approach to validating application changes without the complexity of orchestrators or full-fledged compute infrastructure. Ultimately, ACI empowers organizations to execute these specific workloads with enhanced agility and reduced operational burden. This slide explores the fundamental differences between Azure's core compute paradigms: infrastructure as a service, platform as a service, and serverless computing. Infrastructure as a service, or IaaS, delivers virtualized computing resources over the internet. With IaaS, organizations provision and manage virtual machines, storage, and networking, providing the highest level of control over the underlying infrastructure. This model is ideal for migrating existing on-premises applications or for scenarios requiring specific operating system configurations. Platform as a Service, PaaS, offers a complete development and deployment environment in the cloud, abstracting away infrastructure management. Azure handles the operating system, server hardware, and network configuration, allowing developers to focus exclusively on application logic and data. PaaS solutions accelerate development cycles and reduce operational overhead. Finally, serverless computing represents an event-driven execution model where Azure automatically provisions and manages the required infrastructure. With serverless, such as Azure Functions or Logic Apps, users pay only for the compute resources consumed during execution, eliminating server management responsibilities entirely and enabling highly scalable, cost-effective solutions for event-driven architectures. Selecting the appropriate Azure Core Compute service is a critical decision that directly impacts application performance, operational efficiency, and cost. Several key factors must be thoroughly evaluated. First, application requirements are paramount. Consider the specific needs of your workload regarding processing power, memory, and storage. Evaluate desired performance metrics, anticipated traffic patterns, and the level of scalability required, whether it's horizontal, vertical, or event-driven. Additionally, assess integration requirements with other Azure services or on-premises systems. Second, cost and budget considerations are essential. Analyze the various pricing models associated with different compute services, including pay-as-you-go, reserved instances, and consumption-based billing. Evaluate potential resource utilization, idle costs, and the overall total cost of ownership. Optimizing resource allocation directly contributes to budget adherence. Third, management and operations dictate the level of control and operational overhead you are prepared to assume. This includes evaluating the need for full infrastructure control, the benefits of platform-as-a-service offerings that abstract away underlying infrastructure, or the efficiency of serverless computing where infrastructure management is entirely handled by Azure. Consider your team's existing skill sets, automation capabilities, and compliance requirements. A well-informed decision across these factors ensures optimal resource utilization and strategic alignment with business objectives. This slide explores the critical domain of integration and hybrid scenarios, demonstrating how Azure Compute services are designed to operate cohesively and extend capabilities beyond the cloud. Modern applications frequently demand the combined strengths of multiple compute platforms. For instance, a complex solution might utilize Azure Virtual Machines for legacy applications or specific infrastructure requirements, Azure App Services for web applications, and Azure Functions for event-driven serverless components. These services are not isolated. They are engineered to integrate seamlessly, often leveraging Azure networking features like virtual networks and service endpoints to facilitate secure communication and data exchange, thereby creating robust and scalable application architectures. Furthermore, the strategic importance of hybrid scenarios cannot be overstated. Organizations frequently possess significant on-premises investments that must interact with cloud resources. Azure addresses this through services such as VPN Gateway and ExpressRoute, providing secure and high-bandwidth connectivity options that effectively extend your on-premises data center into Azure. This enables seamless data synchronization, disaster recovery strategies, and the migration of workloads at your own pace. A pivotal enabler for hybrid environments is Azure Arc, which extends Azure management capabilities to resources hosted outside of Azure, be it on-premises servers, Kubernetes clusters, or other cloud providers. Azure Arc provides a unified control plane, allowing for consistent governance, management, and security across your entire IT estate. These integration and hybrid capabilities ensure that Azure Compute services can meet the diverse and evolving demands of any enterprise, regardless of their existing infrastructure or architectural preferences. Effective monitoring and management are paramount for maintaining the health, performance, and security of Azure Compute resources. Azure Monitor serves as the foundational observability platform, collecting and analyzing telemetry data from across your Azure environment. It provides real-time insights into resource performance through metrics, captures operational events via activity and diagnostic logs, and enables proactive issue resolution with configurable alerts and dashboards. Complementing this, Azure Automation streamlines routine operational tasks. It allows for the creation of runbooks to automate processes, provides configuration management to ensure desired state across your infrastructure, and facilitates update management for consistent patching. Finally, Azure Defender for Cloud offers robust security posture management and advanced threat protection. It continuously assesses the security state of your compute resources, identifies vulnerabilities, and provides recommendations, while also detecting and responding to active threats. Together, these tools form an integrated suite for comprehensive control and oversight of your Azure Compute services. Protecting your Azure Compute workloads is paramount. Our first best practice involves robust network security. Implement network security groups to filter network traffic to and from Azure resources in a virtual network, and deploy Azure Firewall for centralized network security policy management, providing advanced threat protection. This isolation and control are critical to preventing unauthorized access. Secondly, strong identity and access management are fundamental. Leverage Azure Active Directory for centralized identity management. Enforce multi-factor authentication for all administrative and privileged access, and rigorously apply the principle of least privilege. This ensures that users and services only have the permissions necessary to perform their required tasks, minimizing the attack surface. Finally, continuous monitoring and proactive posture management are essential. Utilize Azure Security Center, now part of Azure Defender for Cloud, to gain a unified view of your security posture, identify vulnerabilities, and receive actionable recommendations. Integrate Azure Monitor for logging and alerting, enabling real-time detection and response to security incidents. Regular audits and adherence to compliance standards further solidify your defense. This module provided a comprehensive overview of Azure Core Compute Services. We explored the fundamental capabilities of virtual machines, appreciating their flexibility for infrastructure as a service scenarios. We then transitioned to platform as a service offerings, examining Azure App Services for web application deployment and Azure Functions for event-driven serverless computing. Finally, we delved into containerization with Azure Container Instances, highlighting their efficiency and portability. Mastering these services is pivotal for designing scalable, resilient, and cost-effective cloud solutions. Looking ahead, your next steps involve applying these concepts through hands-on lab exercises, analyzing real-world architectural case studies, and delving into advanced optimization techniques to further refine your Azure compute strategies. This foundational knowledge empowers you to make informed decisions for diverse workload requirements.